Well, great. Fantastic. Let's get some energy in for our next speaker here. We have with us today Mr. Jeff Weatherford. Jeff has been an IT professional for over 25 years. He's a United States Air Force veteran. He's worked his way from system administrator to enterprise architect and then moved into DevSecOps. He's spent 18 years in the U.S. DoD intelligence community, and he is one of the VetCon admins and staff members. He likes all types of rock music, nice cars, motorcycles, and pirates. And so with that being said, hand it over to you.
Thank you, thank you. All right, everybody hear me okay? All right, well, first of all, thank you for showing up. I know it's lunchtime, so that means you guys really want to be here, which is awesome. So our agenda real quickly, what are containers? What are they not? Some container hardening practices, some advanced concepts, and then we're going to talk about the software supply chain a bit. Obviously, that's kind of a hot topic now with the whole XZ thing. I'm sure a lot of you have heard about that. Again, who am I? There's your stuff up there, my LinkedIn, an email if you want to get me. I don't post on X. I do lurk, so I didn't really feel it was worth my while to put it up there. So yeah, and right now, my current position, the big thing to take away from this slide is at the bottom, is I am the subject matter expert for container hardening on Platform One's Iron Bank. Anybody here know what that is or heard of Platform One or Iron Bank? Okay. All right. Some assumptions that we're going to make here, that you've heard about containers, you have a rough idea what they are, you have a basic working knowledge of the Linux command line, you know what some knowledge of a CI/CD pipeline, and that you're going to put a container in some kind of orchestration layer. Just to make it useful. By the way, I'm terrible at slides. There's going to be a lot of walls of text. I apologize in advance. There's a lot of slides, so buckle up. What this talk is not, I'm sorry, I'm not going to teach you how to break into containers or break out of them. We'll talk a little bit about that, but I'm not. There's no 0 days here. This is kind of an introduction. That's how this is really kind of structured, is so that way everybody gets something out of it. What are containers? And the big thing for this one here is that bottom one. Why is it important from a security context? How are we going to think about security when it comes to containers? Containers are not virtual machines. I can't tell you how many times I run into this. They don't have their own kernel. They don't have their own memory. They don't have their own network stack, right? You share memory with everything there, which is why there are certain attacks that can be so dangerous when it comes to containerization. They are not sandboxed by default. Keep that in mind. By nature, containers are ephemeral. Treat them as such, right? You've heard they're not pets, they're cattle, right? Shoot them in the head. You have to treat them like they don't exist, essentially, that they exist in the ether. And so what that means is you don't want to have a lot of stuff that is stateful in containers if you can avoid it, for that very reason. One big problem that we have when it comes to container security is how we think about them. I touched on that earlier, and that's the one right there, the DoD STIGs. Have you all heard of the STIGs, the STIG guidelines? All right, well, the DoD, in their infinite wisdom, decided that we had this really nifty technology, and so what we're going to do is we're going to apply our old methodologies to thinking about it, and so we're going to apply STIGs to containers. 99% of the STIGs out there don't apply in a containerized environment. There are some that do, but again, that goes back to the containers are not virtual machines. Quit treating them like they are. They have more in common with the chroot jail than they do with a virtual machine. Another way to think about it, they have more in common with JRE than they do with a virtual machine. Now, so we've all heard of Java runtime, right? You have, that executes a jar file, usually as your Java program. Same kind of idea. Only Java actually has a whole lot more isolation built into it than containers do, by default with the OCI and run C. Containers are not a security boundary. So this goes into the whole idea again that containers are not sandboxed. So they can communicate freely within their own namespace. They can read write to their host system. There's an example there. Anything that the container can see or the spawning user can see, the container can see. because that user can alter that container to see anything that user can see. So you can do interesting things with containers, like make DOS attacks worse. You can see there by consuming CPU resources. Why might that be? Well, a lot of times there's constraints. People will sit there and spawn a container, and they won't constrain it, right? They won't tell it how much memory that container is allowed to use. So by default, it's going to use whatever it can. So it makes it a good way to get your out-of-memory killer to start going crazy. If you misconfigure them, you can communicate across namespaces. Your namespaces are really your only isolation when it comes to a container. Your security boundary here is the host system, right? That's your nuclear thing. Because if I get access to your host that you're running a container on, I can do anything I want to those containers. I can modify them. I can inject binaries into them. I can copy files into them. Right? I can do whatever I want to any one of those containers. So you have to protect the host. Sorry, just kind of organizing my thoughts. What this means is you have the traditional vulnerabilities that the software already comes with, right? All the CVEs that get applied to whatever software you happen to be running, plus potential vulnerabilities in your runtime, whether it's Docker or Podman or whatever. There is nothing about running in a container that's going to make you safer. People assume that's the case. It just simply is not. You have to assume everything inside of a container is public, everything is visible, no special sauce, no certificates, no secrets, those kinds of things. I did throw this slide in here kind of last minute because I don't know if you guys heard about the sneak. They came out with these CVEs that they found called leaky vessels that have to do with the container runtime. All container runtimes were affected by this that use runc, so that's Podman, Docker, all that. I threw it up there. Take a picture if you want. I'm not going to get into the gory details of this container breakout, but it's something that you may want to research on your own. So this is just to highlight that your containers can actually be a source of vulnerability to your system pretty easily, actually. My big side rant here. This is a big one. Again, containers are not virtual machines, so quit putting big monolithic programs in containers. Stop it. Stop it, stop it, stop it. All your Atlassian Jiras, all your ServiceNows, all that stuff, quit putting that stuff in containers. Yes, I know they come out with officially supported containers from the vendor. This is everybody jumping on the containerization bandwagon saying, oh, looky, shiny container, right? Stop it. That's not what containers are designed for. That's not how they're used, okay? That's not what they are. Let me give you a perfect example here. I don't have a slide for this, but the largest Jira implementation in the world is on a secure DoD network, on a top secret network. It is bigger than Atlassian thought possible until we showed them that it was. The guy who built it's a personal friend of mine. Anybody here want to hazard a guess as to how many nodes that Jira cluster is? No. 6. It is 6 nodes. They are enormous nodes, but they're 6 nodes. Reason why? A lot of these applications, a lot of these monolithic applications, scale vertically, not horizontally. So keep in mind, if you're containerizing something, generally speaking, your model is going to be to scale horizontally. I'm going to spin up a bunch of little things to do one thing and then scale it back down again, right? You're not scaling up, you're scaling out. So, I put the old quote in there from Jurassic Park because this is a new technology, everybody thinks it's shiny, so everybody's jumping on to use it. Use cases, people. You need to make sure that your use case for your software goes with the technology that you're using. Okay, enough side rant. How do we build containers? This is just kind of some intro container stuff. Okay, we have a Docker file that describes a container. There's a reference there for the Docker, all the Docker directives and how they work. You use some kind of builder. Docker has its own. Builda is the builder that Red Hat favors. It's an open source one because Podman, as a runtime, doesn't have its own builder. So they have a separate binary for that. And then what you're going to do is once you build that, you're going to put that resulting container into a container runtime, or sorry, a registry of some kind. Basically a library, a place you can download it from. Okay, what are the security implications of building containers? Well, we'll start with layers. So you can see right there that there are 3 container directives for the OCI spec that will add a layer to your container. Run, copy, and add. But the big thing here is each one of those layers, you can peel that layer back. There's a SHA value associated with each layer, and I can go back in that container image and I can pull from any layer I want. So let's say, for example, that I build a container and I say, okay, install this software, configure it this way. Now here's all my, and then I have a separate run statement that, okay, here's all my security lockdowns. Cool. I just pull the layer above that and all those security things that you put in went away, right? So one thing that you want to do when you're building here is you want to consolidate as many of these layers as you can. And you certainly don't want to leave out security stuff in its own layer. Don't do that. This, like I said right there, it'll undermine any hardening work that you've done. Now keep in mind, containers are just a piece of software. They're really kind of very similar to an RPM. Right? It's a piece of software that is a file. It's a tarball. It's got some extra metadata in it, a few things like that. But at the end of the day, it's a tarball. So you can modify it in any way you want. End users can and will modify containers at runtime. So you have to make that assumption. All right. So this is why it's like providing an RPM. And Red Hat provides you an RPM, or Debian provides you a deb, and it's going to be a series of defaults that are saying, hopefully, some software, some documentation maybe, and that's about it. They assume that you're going to configure it at your end, and you're going to be responsible for the end security state of that piece of software. Containers are no different. You have to treat them like an RPM, that it's something that can be misconfigured, will be misconfigured, and any sane defaults you put in there can and will probably be overridden. Does that mean we shouldn't give them sane defaults? No, we should. But keep that in mind. People think that containers are some special thing, and they're really not. Like, there's not much to them when it comes to, what can we actually do security-wise. But we will talk about that. So if we do want a hardened container, we want to make it, a little bit harder for somebody to abuse. Well, what are we going to do? Well, we need to, look at our threat model. We want to look at our threat vectors. We want to ensure that we see as small a footprint as possible. Again, we're talking about attack vectors, not attack footprint. Vectors and footprint, 2 different things. Footprint is how big something is. A vector is an actual way in. The vectors are what matter. I mean, you'll hear people scream from the high, the hills that when it comes to containers, we need to strip out all the excess software. We need to reduce our footprint and reduce our footprint. Well, reducing your footprint is fine and dandy, but if the same vectors are still there, the same attack points are still there, you've accomplished nothing other than shrinking size, right? So keep in mind that you want to focus on the attack vectors, the ways in. Configuration, remove dev tools and other unnecessary libraries. GDB is not your friend. In fact, I think I say that later in another slide, right? Do not leave compilers in. Don't leave tools like GDB, Netcat, curl, all these things that are unnecessary to the running of your binary. Now, it might be, you may need those to build, but for the actual running of the application, you don't need, leave them out. In fact, what you should do is remove even your package managers at the end of the day. Now, at Iron Bank, we don't usually do that. Why? Because we understand that we are not the end state of that container. We know that our users are going to go take that container, install their own software, do their own thing with it, and then use it, right? So we're giving them a base, so they need to be able to install things or make some of those modifications. But as an end user, if you're putting something in production, your final container, remove that stuff. Don't give any tools that you can avoid to your adversaries. But the most important thing is that last one. Configuration is all important. Right? Like I said, you can override all the same defaults pretty easily. You can do it from the command line, you can do it in a Docker file, you can do it from a Docker Compose YAML, you can do it in a Helm chart. I mean, take your pick, right? There are ways that you can override all that stuff. And speaking from not only experience, but to one of my friends who's the CEO of a security company who does SOC monitoring and all that, most of your breaches, the vast majority of them, are not 0 days. The vast majority of them are misconfiguration. Someone, leaving default credentials, somebody leaving, or, misconfiguring something, leaving a port open that they shouldn't, et cetera, et cetera. But at the end of the day, it's misconfiguration. It's human error is the vast majority of breaches, right? Why do you think phishing is so successful? They focus on that human element. Well, why go through the trouble if it's so easy to break things apart and misuse them? Well, obviously there's some regulatory stuff, right? There's healthcare, financial, federal agencies. Anybody with sensitive data is going to want to kind of make things difficult for an attacker, I would say. And there are some things that we can do and to make these, a more difficult target. I know I've said that a few times. I'm actually going a little faster than I thought. Okay. So what does it look like? Low-hanging fruit. Do not run your containers as root. Don't run your containers as root. Okay? If you can avoid it. Obviously, there's a few things out there that need root privileges. They need that ring 0 access to the kernel. Ceph is one of them. It's a file system manager, right? So I would probably argue anything like that you probably don't want to put in a container. But it's not up to me. If you do need those kinds of privileges, there are ways to grant those syscat privileges to the container without necessarily granting it as root. The details of which are going to vary depending on the container and what you're trying to do with it, but just keep that in mind. Do everything in your power to not run as root. By the way, Docker runs as root by default. Keep that in mind. Docker requires root. That's why Podman is why Red Hat came out with Podman, is because that can run in user space. So we talked a little bit about the next one. Don't install unnecessary software packages. If you don't need it, don't install it. It's really quite that simple. You have ways of doing that. You can tell it, adding no docs to your RPM command, or there's ways to tell it, don't add unrequired dependencies, depending on your package manager of choice. So refer to your documentation on how to do that, because I don't know which one you're going to use, but they all have something like that. One thing that we always do when we start, if we have a need of a bunch of system stuff, we'll start with a base, Red Hat, CentOS, Debian, Ubuntu, whatever. Run an update. That's the very first thing you should do. Make sure you have the latest packages. Now, one thing that we do is we build every 24 hours at a minimum. So every container is going to get rebuilt within 24 hours for this reason. That way, anytime a CVE drops, a new patch comes out, in less than 24 hours, it's patched and published to the registry. You should have that mindset, because the amount of CVEs that we have to deal with every day it would surprise you probably, especially because we're going across systems, right? We have to worry about supporting Debian, we have to worry about supporting Red Hat and all that, right? So it is what it is, and make sure that you're doing your GPG checking, right? When you're building from appropriate sources. This is where we start to talk about software, the software supply chain. You need to ensure you're checking these things. Now, would that have stopped you from the XZ thing? No. But it's a good way to still avoid man-in-the-middle of attacks of people trying to inject poison packages into your containers. Use multi-stage builds if appropriate. This is where we talked about if you need to compile software, right? You need to run a compiler, whether it's Go, GCC, whatever. You usually want to do that in some kind of build container, right? So you'll have a container that you'll call it builder, and there's ways to do that. The multi-stage documentation's in the Docker docs. Like I don't want to go through things that you can easily look up, right? So the idea is you do your compilation, and then you copy the artifacts that you need into another container, and that has just your runtime, just your binaries, and that's it. And that way you don't have to worry about uninstalling the compiler. You don't have to worry about it leaving stuff behind that could be potentially used against you. Now I will say this. Updating and installing from packages, you're going to hear a lot of people sit there and say, oh, build from source, that's the only way to be secure. No, it isn't. And I'll tell you why. It is more secure if you audit every single line of source code. Who here has enough time to go through the Apache source code and audit it? That's what I thought. So you're better off in many cases from a reality perspective, not a theoretical perspective, but a reality perspective of using official sources for your builds, using official debs, using official RPMs, because not only are there your eyes on that, but you also have the security teams of those sources looking at this stuff as well. Is that going to save you 100% of the time? No. Nothing's ever going to save you 100% of the time, but the idea, and I think that we've all heard this many times before, is defense in depth, right? We take a bunch of little steps so that way somewhere, hopefully in the chain, something will get caught, right? So that's what we're doing here. And use other people's security teams to your advantage, right? I mean, I know Red Hat has a whole lot more security people on staff than I do. So it is what it is. All right, more low-hanging fruit. All right, you want to scan your registry. There are various tools to do that. You want to make sure that you're scanning constantly. You want to have a central repository, a central registry. That is your one source of truth, right? You don't want to have a bunch of registries scattered all over hell and gone, because it's a lot more places to check and it's more places that are vulnerable. So you want one robust registry that you trust, that you're constantly scanning, and has cryptologically verifiable artifacts. Okay, we're talking SBOMs, the software bills of materials, things along that, the SHA values of your images, things that you can verify cryptographically that nothing has changed and that everything is still as it should be. You definitely want to use so this, we're talking about building from upstream. You want to use some kind of proxy generally to perform validation of your upstream sources, to check those SHA values to make sure that things are coming in. So like we build in a 100% offline environment when we're building containers. We have a special way that we go out and we pull that source code, that RPM, that deb, that whatever, that binary file, however, that container, there's a variety of different ways we do it, copy it into an offline environment that is not connected to the internet, and uses that to build. And it cryptographically, I'm going to get that word right one of these days, validates every single object it imports to build that container. All right. Few other things. I know these are in no particular order, by the way. This was kind of a stream of consciousness. It just kind of is what it is. In your Docker files, use copy instead of add. We don't want to use add. Add is bad. Okay? They do the exact same thing with one major difference. Add will follow URLs and it will untar things by default for you. It tries to be helpful. Well, that becomes a case of stop helping me, right? That's a good way to get things injected into your container that you didn't intend. So always use copy after you've downloaded whatever it is and then cryptologically verified that that is in fact what you meant to put in. Okay. We talked about the run statements a little bit. We want monolithic run statements. we want to compress as many copy statements into one as we can, just because, again, layers. Not only for pulling layers, but also layers mean more memory, more resources. It's just more efficient to have as few layers as possible. And again, multi-stage builds, there's a reason why I said this again, this is important, is to reduce the amount of stuff in your final container, use multi-stage builds. All right. This is kind of what it would look like. This is just an example that we pulled from from Iron Bank. Is you'll see that from build. That's what you can tag you'll have something as something, right? So you sit there and say from this container as build, and then you can use copy with the from flag there to copy stuff into your current container from the one that you had tagged as something else. That tag is arbitrary, by the way. It doesn't have to be build. You can name it whatever you want. Suid JID. Yeah, don't do it. Go and look for everything that has those bits in there and unset them. Why is this an issue? Well, especially if you have access to something like a debugger, now I have a way that I can inject shellcode into memory or anything else into something that is running as root. Bad idea. Make sure those are gone. There should be no reason for something to need that capability within reason. Apache does some odd things, but it has kind of its own SU built into it because it's Apache. But keep that in mind. Anytime you see this stuff, anytime you just get rid of it. Let's see. Clean up after yourself. This goes into, after you've downloaded it and installed it with RPM or DNF or Yum or whatever, go tell it to remove the stuff that you don't need, clean up. Again, this is, I talked about it a little bit earlier, but we do this, we build from in a sterile environment, disconnected from the internet. Scan your stuff for viruses. That should go without saying, but it's up there just so nobody forgets. And scan it before and after, all right? And once you upload it, before you upload it into the registry, you scan it. You also want to scan your sources as you download them. That's kind of a no-brainer, but you'd be surprised how many people skip that step. And remove the secret. So we talked a little bit about this. I'll go into a little bit more detail. You don't want to store certificates because anything inside your container is visible to the public and modifiable, right? So don't put your private keys in there. However, if you need to be able to do things like use PyPy to install Python modules, you're going to need to leave the certs, that are in there for a lot of the Python packages to actually function. So that's why I say, don't remove the stuff that will break the package managers unless you're trying to break the package managers. If this is your final step before publication, go ahead and break the package managers, right? But just be in mind, be aware if you just sit there and look for anything name.sir.pem, that kind of stuff and delete it, you could cause breakage. So just be very careful of that. Python's notorious for that, of having all kinds of certs that come from PyPy. Now, granted, Python has a lot of issues with PyPy in general and malware being in there, but that's a different discussion. All right. If you do want to delete your certificates, there's ways to do it. You give you the two examples with xargs and with execrm. I'm not going to fight that holy war for you. I'm sure many of you have heard that. Which one's better, but doesn't matter. I really don't care as long as you get rid of the stuff that you need to get rid of. Now, there are tools out there that will help you. Trufflehog is probably one a lot of you have heard of. We use it extensively. It is prone to false positives. Just be aware of that. Anchor is something we use a lot, and it can detect secrets, and you can actually configure it in your pipelines to actually stop pushing to the registry if it detects those secrets. But again, be aware of false positives, especially with Python. It's almost like I've said that before. I wonder why. Oh yeah, that's right, because Python's Python. Just something to be aware of. I don't know why Python does that. Side note, I mean, Git doesn't have that, Go doesn't have that issue. Ruby doesn't really have that issue. It's a Python thing. Let's see. Okay. Minimizing layers. We talked a little bit about this. There are some things here that I do want to talk about specifically, though. You notice how in this one monolithic run block that we end with the double ampersands. The reason why we want to do this is because we want to make our run statements one big long command chain. That way, if any one step fails, the container build fails. And we want to know that. Because I promise you, you put semicolons in there, it will work. Not only will it work, but if one of those commands fails, it'll go ahead and skip on to the next one. And we'll keep running. And because the only time it will actually fail the build is when it gets a return code that's non-zero. Right? But it doesn't check the return code of every single command that it runs. It checks the resultant of the very last one. So if those were all semicolons, every one of those commands could fail. As long as the rmtac rf at the bottom works, the build will succeed. And you will probably have something in your container or not have things in your container and you're going to spend a lot of time debugging it. So save yourself some grief and use the double ampersands. All right. Let's see. You can see, removing yum cache. That all goes into, cleaning up after yourself. So this just gives you an example of some things. All right. So again, wall of text. I apologize. We've had problems. XC, I know I mentioned that before. This is an example, right? You have to validate your upstream software and watch you watch your supply chain. Now, let's see. You of course you want to set up all your canaries, your AVs, all that stuff before building. You want to do it after building. You want to keep doing it. It's a continuous process. I don't want to bore you with that. Container user. Again, what we said, not as root. So what do? Usually we'll either create a user or we will, you can use just a UID. Sometimes you need a full-blown user with a home directory and all that for the software to work. It depends on your software. Keynotes here, we try and use SBIN no login wherever we can. We're not logging into containers, folks, generally speaking, right? You want to avoid people getting shells easy. Right, so don't allow them in. And a pet peeve of mine in there is not upping the sysuid max if we are making these, or we're telling user-ed that we're making system accounts. Otherwise, it'll throw errors in your logs. It'll still do it, but I like clean logs, and I don't like chasing stuff in my logs that I know is benign. So just do that. That's why login.defs exists. So make those changes as necessary. You can see here that we're using a command that we're firing off Python 3, so they're going to get a Python shell in this particular case. So you want to be very careful as to what this container is actually going to do. You usually use an entry point or a command to specify what it's going to run. Yes, you can use scripts. We use scripts heavily to alter the or to set up environments and do things that we need to do for a process to run correctly. So just keep that in mind. Let's see. Looking at, okay, we got another 15 minutes or so. Okay. We're going to talk a little bit more here about some more advanced concepts. Okay. secure your pipeline. We talked about software supply chain, your software supply chain. How do we do that? Well, it's not just your sources, right? So we have all these tools, and I've listed a bunch here. You can use your tools of choice. Okay, I'm not a shill for any particular company. I don't care which ones you use, but you should use some of these tools. And I'll, right there in the parentheses again, I will let you read as far as what they do. Kyverno is a big one for doing your policy engine. You must have something in your environment that says what containers can and cannot run. If you just let any container run, you are asking for trouble. Right? You need to have some kind of policy stating which ones are allowed to run and which ones are not, and by default deny. And Kyverno does that. You want to have your multiple scanners of various kinds. And there's several listed there: Twistlock, Encore, OpenSCAP, Nessus. We use actually all four of those. And why is that? It's right there in the text. You don't trust a single source. Not every tool catches everything, and not all tools will give you the same results. Right? So what you have to do is you need to use multiple tools to get a holistic picture of what is actually in your containers, what issues might be there, what CVEs might be there, what configuration items might be caught by one tool that is not being caught by another. Right? Same thing with your virus scanners. Don't rely on ClamAV. Okay? Don't rely on McAfee. Right? Symantec, whatever. Don't have a single source, because the same thing, just like your container scanners, you will miss things. Right? You need to have multiple sources to get the most complete picture. I talked about SBOMs briefly. There's what a software bill of materials is. There's a link. I'll let you do the reading on that. And basically, it is a list of what is in each container. In our case, because we're talking about containers, what software goes in there to make it up, hash values for anything, so you can actually go and verify individual pieces of a container. It's a very important thing to have. And cosign for signing containers when we publish them, because again, we're cryptologically guaranteeing that the container that we publish to our registry has not been modified in any way other than, it's been done by us, right? It's just like signing an RPM. So same deal. All right, using container and container builds. So if we're going to build containers, we probably don't want to do it on bare metal for a variety of reasons. One thing is if we detect something in our pipeline that some container got corrupted, we can kill that container and respawn it, right? And they're ephemeral. So cool, problem gone. We also want to make sure that we're not storing packages on the host system, right? So since they're ephemeral containers, you have the container spin up, do your build process, download whatever it needs to inside that container, and then when that container is done with its job in the pipeline, it goes away. It means all those files go away, all that memory gets freed up, all that stuff is gone. All right, that's what we want. And of course, you can scale your builds. It makes it a lot easier to scale horizontally, because building multiple containers is something that scales horizontally. This would be a case where containers work, right? So, I'm trying to make sure, hoping that we get to the Q&A section here. As far as deploying containers, don't automatically push stuff into prod, all right? That should be a no-brainer. You'd be surprised how many times I see it. You want to have some kind of human gatekeeper that actually, yea, verily, they have some kind of testing that's been done, something along those lines. And don't pull from prod, don't pull something into prod without some kind of human gatekeeper. Don't do it. Separation, this is a big one. Do not put your infrastructure stuff in pods, containers in this case. So quick side note, when we're talking about Kubernetes and other runtimes, they'll usually use what's called a pod. Pod is simply the lowest addressable unit. You can have one or more containers inside a pod, but all those containers will share the same network address, the same ports, yada, yada, yada. So for the most part, generally it's a one-to-one unless there's sidecars, but we won't get into that. That's more advanced stuff. But the idea here is that you do not want your applications or your pods or your containers that are handling data to be on the same physical nodes as your infrastructure. Now you're going to have kubelet if you're running Kubernetes on all your compute nodes, or otherwise they're not compute nodes. But that being said, you know, your DNS pods, your ingresses, your etcd, especially your etcd, all that kind of stuff, you want to be segregated into management nodes. And then you want to have the dirty user nodes only running user workloads. All right. Now, there's actually some regulations about this when it comes to things like HIPAA and whatnot and separation of data, because they've realized, oh yeah, that's right, containers are not the security boundary, the node is, so you will segregate your data and your workloads via taints on, you know, Kubernetes tenants saying, okay, this group of nodes will run my HIPAA data, this group of nodes will run my non-HIPAA data, et cetera. And then this is, you know, our management nodes, no touchy, right? You know, that has, you know, the API server and that kind of infrastructure stuff on it. Obviously, there's exceptions to every rule, but we're talking about just kind of general use cases here and kind of just kind of best practices. Using centralized, what do we always want to do? We always want to use centralized deployment strategies. I know, wall of text, I apologize. We want to use our security tools like Open Policy Agent and Kyverno, right? We want to make sure that we're only running workloads that we know of and that we specifically authorize. You want to, so yeah, always pull on create. So one of the strategies for containers, right? We have to know when we're starting up a container, what we're going to do. So you want to use the always pull strategy to say that anytime I start up this container, I'm always going to pull it from the registry. I'm not going to pull it from cache. Side note, be careful with this, because even if you have an always pull, if the tag for the container has not changed, it's not going to pull it. It's still going to run it from cache, right? So you actually have to flush it and then tell it to repull. But those are things that you may want to consider to make sure that, yes, it slows down your startup time, but that you're always grabbing the latest and greatest container from your registry and that you're not using something that has out-of-date software in it, because that cache will bite you if you're not careful. Yep, and of course, make sure our hashes haven't changed. That's kind of, you know, why hashes exist, right? And you want to do that comparison before you actually deploy things. So this sounds like a lot of custom code. It does, it is. So your pipelines, so when we're talking about CI/CD pipelines, they're going to be fairly intricate things. You're going to be doing lots of things in them. It's not just simply pull and deploy. It's not simply going to be one Helm chart that says, here's all my stuff. Not if you want secure containers, right? You're going to be doing lots of steps, everything from downloading from sources to building containers. You're checking things and scanning things at every step. You're going to check formats. You're going to check your secrets. I mean, there's a lot of things to do. So when people say, oh, I'm going to go to containers because it's going to speed up, you know, my whatever. No, it's not. Not if you're doing it right. So that's, in other words, be wary of shortcuts. You know, we're talking about a lot of stuff here, and all this stuff really needs to be done because again, that defense in depth. All right, almost done. All right, here's some fun attack strategies. You want to play with someone's Kubernetes environment that has done something stupid like let you in? Here's some fun stuff. These are just strategies to go after, like going after the core DNS or the service mesh. That's a fun one. Use LOIC once you're inside. If you can deploy LOIC containers inside somebody's Kubernetes cluster, target core DNS. The whole system will go down. So, yeah, I mean, use containers for DDoS. Use them, for overflowing memory. You use them to exfiltrate data. All kinds of fun stuff. So, these are all different ways that you can mess with containers. And, this is not a comprehensive list. This is just to get your creative juices stirring. Further reading, right? Again, feel free to take pictures. I'll leave it up here for a little bit. These are just various stuff. By the way, if you do have that first slide that has my email, shoot me an email if you want the slide deck, and I'll make sure that I can get it to you. Special thanks to a guy named Chris Renoy, a guy I used to work with. He came up with some of the images and wrote some of this. I redid most of it, but I didn't want to reinvent the wheel. So thanks to him, DC813, VetCon, and my current employers, Platform One. I am on the container hardening team as the SME again. And lastly, Tampa B-Sides, thank you for having me.